name is Jean Millette, and I'm a senior applications developer on InterSystems AppServices team. Our team uses our own technology to develop and maintain multiple systems that we use in-house by other people in InterSystems. I've been working and getting paid as a software engineer for a little over 40 years. I started when I was 2. So today I'll be talking about how we're eating our own dog food, drinking our own champagne, using our own technology to support the business reporting work our sales and marketing teams have been doing. I'll be focusing on how we migrated the data used in those reports from a SQL Server database to InterSystems IRIS. Actually, before I go through the agenda, does anybody here use SQL Server? Can I talk to you later so we can discuss pain points to see if you shared the same pain that we had? All right, thanks. So here's the agenda of the presentation. We'll start with the history of the project, including a description of the original implementation. Then we'll highlight problems we had with that original implementation that used MS SQL Server. Over the next few sections, we'll talk about our solution, what it was, how it was implemented, and what benefits we realized from that solution. I'll then talk about what we learned while we developed that solution, and then I'll finish up with some future work, future plans for the project. So InterSystems started using a third-party CRM system back in 2019. As part of that, we chose Power BI as a tool for creating reports from that CRM, as well as from other applications that we had in-house, like our billing system and our licensing system. To keep our business information very secure and in-house, we opted to implement an on-premises version of the Power BI report server. And we made those reports available to everybody who had access to that report server in-house. So the Power BI report server requires MS SQL Server to store the report server's metadata. Who created the report, where is it located on the report server, what the refresh schedule is like for that report. And also, SQL Server also logs how long each report takes to refresh from the database. So since we already had this, the SQL Server instance, and the team working with the third-party CRM had some Microsoft experience, we decided the most convenient and quickest way to get our reports, some data, was to use that same SQL Server to store to create our data lake, reporting data lake. So here we see the original initial implementation of our business intelligence system. These rectangles on the left, these apps, those are the various applications that were the sources of the data. The SQL Server hosted not only the report server database that holds the metadata, as I mentioned before, but we also had these data sync jobs that would sync the data from various applications into the SQL Server database. That is the BI data lake. We also had our Power BI reports would get data from that BI data lake. And the report server just shows the hierarchy, the folders of where all the reports are. And that information is stored in the report server database. And all those connections, like in the data sync jobs, those are either ODBC connections between like the CRM package and the jobs that are running to populate the data lake, or for some of the other applications, we used REST calls or SOAP calls to get. We used Python scripts as part of the data packages, the SSIS data packages that we use for getting the data. So when we originally created this application, this data lake, we had 20 SQL Server tables, actually about 24, and then we had a similar number of jobs running. to populate those tables. And we had about 100 Power BI reports. We're now up to like 150, and that number continues to grow. So we ran okay for a while with this configuration handling the load that we describe here. But then came the problem. As time went on, we got more and more reports. We need more data sync jobs. And we learned that the system, the SQL Server system, was quite brittle. Each working day, the first job of someone on the team was to check if all the data sync tasks had run. On many mornings, at least one job had failed, leaving like the reports with no data or something with no data. Also, around a year ago, a little bit more than a year ago, we lost our most experienced SQL Server maintenance development person. And so the job of maintenance and future development fell to the rest of the team, who didn't have as much experience as that guy did. Also compounding our problems, we had a not ready for prime time development environment. We didn't have any source code management or any management of changes to those SSIS packages that we used to build the data tasks. And we had one machine, the production machine, that we use for deployment and test as well, which is not an ideal situation. So as things were getting more troublesome, we finally had that light bulb moment at the end of September 2022. Why not use InterSystems IRIS for our business intelligence data lake? We knew IRIS was a fast database that could handle a lot more data than we currently held in our SQL Server data lake. Also, we were an IRIS shop, so we knew how to take advantage of InterSystems IRIS, a special sauce, which is the availability of object-oriented tools to work with the data, along with traditional relational access to the data as well. So, you know, like Microsoft SQL Server, we could use relational tools to update, build, get reports out of the database. But additionally, and unlike SQL Server, IRIS provides an object model that we use to create instances of objects that end up being rows in the table of the data lake. Also, along with the more flexible development environment, we expect other benefits with our move to IRIS. We'd have code instead of SSIS packages. This code was stored in text files, which is easier to use source control management tools on. And we're using the tools that our team knew, so we had a pool of people ready to help. So once we decided what our target solution was going to be, InterSystems IRIS, we needed to figure out how to get there. So we had the benefit of an existing working system with a decent overall architecture. We knew what needed to be done. We took advantage of the similarities between SQL Server and InterSystems IRIS systems to ease that transition. So the system similarities are listed here. We saw, oh, these are the SQL Server tables we had. Let's make some IRIS tables with the same names. We had some SQL Server jobs. We're going to need the same IRIS tasks to do those jobs. Both environments also had tools for querying data and managing tasks. Microsoft SQL Server had the Management Studio, and we have the Management Portal. So here we see in blue the three pieces that we're going to have to change: the data sync jobs, the data lake, and the Power BI reports. So let's get into the mechanics of how we got there, of the migration. So here's we see the planned order of attack. We'd migrate the data first, then we'd rehost the data sync tasks to keep those tables fresh with data from the apps, and then we'd migrate the Power BI reports to use the new data lake. So first up, migrate the business intelligence data from SQL Server to IRIS. To do this, we connected dbeaver, a free third-party tool, to the SQL Server, and started migrating tables over into IRIS from SQL Server. For each table we found on SQL Server, we used the tool to bring over the table schema and the data from that table into the same similarly named table in IRIS. Special sauce alert. As DB migrated each table, because of IRIS's special sauce, I mentioned earlier, and that we don't talk about enough, we got a new object script class code definition file as well on the system. So, and as mentioned earlier, for me and for many on the team, working with code is much easier and much more straightforward than doing development with tools provided by the Microsoft Visual Studio for building SSIS packages. So if I can use Don Woodlock's quote, those MS tools made us work for them. So while object script code is not a natural language, it was one that we and VS Code and the compiler understood, so we knew quite well. So the environment was generally just simpler for us. So with our special sauce going forward, if we needed new data, we had a couple of ways to do things. We could use a relational approach, get the create table script from the original database and adapt it, bring it to IRIS and build the table that way. Or we could just use a copy of an existing IRIS class, copy it, change the name, change the properties for what the original table is like, and we have our table and our class, and we're ready to go. So we got the IRIS database set up with the new schema and populated with SQL Server data. Now how are we going to keep the data fresh with data from the original applications? So rehosting the sync task was the second part of the job. So here's the approach we took. For each of the sync jobs on SQL Server, we looked at what the source of the data was, what table was in the original application. And we identified on SQL Server what table was the target of that sync. Now we had a similar table in IRIS, so we wrote a present sys task definition derived class for these sync tasks. So one for each of the jobs identified in SQL Server, and the tools we use are VS Code, Studio, ObjectScript, and SQL. We also used another set of classes we called AppSData or CRMBI.data, and they were the place where the original source of the data was stored. So whatever way we access the data was hidden in that class. And so in case we had to change it, the rest of the code, the rest of the sync class wouldn't have to change. So it was either SOAP or remote SQL query. Another benefit of those classes was it would send email if, when there was a successful run or a failure, and we'd act accordingly. So now we come to the third set of changes that we made. Migrating the reports to use the new IRIS database. This task took a while, but once we got the process going, we got some good momentum, but there were a lot of reports to do. So we configured an ODBC connection on the Power BI server, the Power BI report server, and to connect to the new IRIS data lake. And everyone who helped migrate, we had a team of people that helped with this migration. They each got a simpler connection on their laptops. So they each used Power BI Desktop, and we had a recipe set up so everybody followed the same steps to make sure that we managed the configuration of those reports. Like we wanted to track the changes that we made to those reports and other steps along the way. The key step was, if people are familiar with Power BI Desktop, was editing each query that, where we got the data. And we just changed one line, the SQL database with its address information to an ODBC data source with the IRIS data lake address. And as part of the steps, the final part of the step was the test. So we would test the migrated reports against the original reports. In general, they were close. If they were close enough, that was good. And if they're identical, that was quite surprising. But what was interesting is the differences that we found were because of issues with the SQL Server. Like IRIS, the IRIS data server actually got more data in successfully into, from the original applications. So voila. After doing the three parts of the implementation, this is what the new Power BI reporting environment looks like. So we have 2 machines now. We still have the SQL Server, maintaining the report server database that holds that metadata that we need for the report server. But now we have a new InterSystems IRIS box with the data sync tasks that have been migrated, the new IRIS database, and the migrated reports that are looking at that database. Just a reminder, this is what it looked like before, and that's what it looks like now. So I had mentioned expected benefits earlier. What benefits do we actually get? So we got better performance, better uptime of task, and easier maintenance. So before I talk about performance, I just want to make sure it's a fair fight. So I'm just showing what the hardware was that we ran each database on. As you can see, they all had 8 cores. They also had similar amounts of memory. SQL Server actually had faster cores and more memory, but it didn't matter. So the first performance test we're looking at was how quickly do the reports refresh? How did the reports, the Power BI reports, they get the data from the database, how long did that take? So what we did was we had 2 versions of the same report, one getting data from SQL Server, one from IRIS, and we refreshed them 12 times. And we looked in report server databases execution log 2 view, where it keeps track of like how long each refresh took, and we computed an average for those results. And we repeated the test with another Power BI report, same test, same report, looking at each of the databases. So what we found is the IRIS versions of the reports refresh more quickly, almost twice as quickly in some cases than the SQL Server. Note that for people familiar with Power BI reports, we use the import feature of to get the data in, and we're going to try, well, it's future plans, but we're going to do the direct query at some point as well, see how that improves performance. So for the, one of the other data flows, you know, how long do the sync tasks take on each system? So how long does it take to get data from the original application into the data lake? So to do this, we did a similar test. We picked a job that went to get the same data into the respective databases and ran those multiple times, timed them, and then took an average of those times. And what we found, and the source of the data was like the SQL Server Management Studio and the task, the management portal from IRIS. So here we don't see that much of a difference. The IRIS is still faster, but just by a little bit. The reason for that is most of the time taken is actually on the original application. So this is like making the request, getting the data, and bringing it back. And that part of the test, that part of the processing, took the longest. So, you know, at the margins, IRIS is much faster, but the bulk of the work is done on the original application. So, yeah, final note on performance with a kind of a funny headline here. A failed task will take forever to run, so it's not going to perform at all. It's going to be much slower than anything else. So, and we did have a few crashes when we were originally setting up the system in IRIS. We tweaked the memory on that machine and did some other work, but since we did that work in April, we haven't had a crash. Nothing has failed, no tasks have failed. Whereas we still are having issues with SQL Server. Those red bars you see, those signify tasks that failed on SQL Server. So the greatest benefit for our team anyways was easier maintenance. We had deep team expertise in InterSystems IRIS technologies. We knew object scripts, host connections, all the stuff we need, native SQL query. We took advantage of AppServices best practices. We used Jira to track bugs, CCR and Perforce for configuration management. And easier maintenance means more time for new features and a happier team. And an extra special personal benefit consists of me getting to come down to this warm, beautiful place to present this to you guys. So just some migration stats. We started with 20 tables that we migrated. Now we're up to 30. We added 10 more tables. The biggest tables hold 2.5 to 3 million records. Most are in the 100 to 300K range. We get sync tasks for each of those tables. And so how many people days did it take, or people months did it take? So we started like September 22, end of September 22, and until I wrote an article that described, what we did, and that CRM BI is now our source for Power BI data. It was the end of April. So about 7 months, and that was with an average about 1 to 1.5 people over that time. And I'll thank some of those fractions of people later in the, So future work lessons learned. So we're planning an upgrade to CRM BI to 2023.1, which should be done in the next couple weeks. As I mentioned earlier, we're going to try different kinds of refresh options for the Power BI reports themselves. The reason I want to talk to you guys about SQL Server is I want to write an article about the development processes like SQL Server versus IRIS, and just see if you had similar pain that we did. We used dbeaver to do our work, but we should have investigated load data, so I'm going to take a look at that as well. And also, for the last couple days, I've learned more about foreign tables, about IRIS BI, and some other things that are in our technology. So we're probably going to investigate that to do some more work with that. Oh, and InterSystems reports, but don't tell the Power BI people about that. Okay, so that 7 to 10 person months that I mentioned earlier was unequally divided among these people listed here. That's why I mentioned the fractions of people, but they all contributed to the migration effort. I mentioned them here as a show of great appreciation. The biggest thanks goes to Cole, who actually is a new person on our team, and he did the bulk of the work early, the bulk of the initial dbeaver work, the creation of the initial sync tasks, and a bunch of the migrations of the Power BI reports. Phil Matos, who's also a young person that just joined, and he did some of that initial work as well. Catherine Sullivan, out of the UK, has done a lot of the report migration, and she'll be continuing on as the Power BI main architect. And we'll be good in hands with her as she continues on that role. And I'll continue to be working as the CRM BI primary architect. So that's my name. At InterSystems.com is how you can contact me. Oh, one thing I forgot to show. Well, I'll show it afterwards. But first I'll say thank you. And let me just show one of the sample reports. So this report was generated from the CRM BI database, and it's what we use to track who's coming to Global Summit. So thank you. Any questions? Are we good? Thanks. Thanks.